Okay, so I want to work with some bisect problems. One of the things that I found my students have a little bit of trouble with is the concept of bisect versus intersect. Okay, so real quick, we'll go with bisect. You can bisect a segment, you can bisect an angle. Let's start with a segment quick. If I have, oh, that was awful. Let me try that again. So if I have a segment, okay, that means it stops. Two endpoints. I know it's weird, but we call it endpoints no matter what. Two endpoints, and if something, let's say, bisects this segment, it's going to hit exactly in the middle. Okay, so this line, let's call it CD. Okay, this line CD could bisect segment AB. They can't bisect the line because it doesn't have any end. So we can't cut it perfectly in half. The word bisect means it's going to cut into two congruent parts. So AB is split into two congruent segments. So that's what we have to understand. Whatever is being bisected, the second thing, is split into two congruent segments. We can call it E. So your conclusion then, okay, what can we say? What's a true statement after this? Okay, so we can come up with this conclusion. And how we have to write it in geometry is that we have to say now AE is congruent to BE. Okay, that's because AB got cut perfectly in half. All right, and that's bisect. Now, intersect, on the other hand, okay, intersect is just two things crossing, but it might not be the middle. So maybe this is A, and B is way over here. Okay, CD can still intersect without bisecting. So in this case, CD simply intersects AB in this case. Right, that's the difference, is it might not be perfectly cut in half. So if you're looking at this may be from here, from A to E, it might be 8. E to B might be, who knows, 14. That's for intersect. Now, when it's bisect, what's going to end up happening is if, say this is 12, A to E, then so is that. And that's the quick bisect definition. So now when we bisect an angle, one of the first angles we start out with, actually we won't do the straight angle yet. So I'll start out with this angle. Let's call it EFG. Okay, now we're going to call it angle EFG. What I mean by that is I want you to move from side EF to side FG. That's what that angle is. We're looking at that interior. Okay, so I'll draw that again, and now we're going to end up adding something to this diagram. So here's EFG. Okay, we're going to add a bisector. Okay, we're going to throw the bisector in there. I'm attempting to make it perfectly cut in half, so H, right? So what I'm going to say is ray FH bisects angle EFG. All right, so there's a few things we could do with this. If we knew how big the whole angle was, say it was 130, you know, each half would be, so I'd say up here, okay, let's say this is 130 degrees. Because of this, these would be both 65s. Right? When it bisects, what we get is we get two equal parts. So what we get is we will get two equal angles from bisecting the original angle. Okay, so that's what we're going to get. So our conclusion here from this, all right, your conclusion, what can you say about it? All right, you can say now that angle, follow the path here, EFG to F to H is going to be, this is the congruent symbol or equal symbol, and we're going to say from, let's go H, angle H to F to G. So that's going to be our conclusion. What does it mean in various problems? Okay, so we'll often get complex problems. I'm not going to make it terribly complex yet, but we might get something along these lines. Okay, so I'll just create a problem here for you. All right, so here's what we might end up saying. First, they'll tell us ABC. This is weird, but they have to say this. That's basically saying, right, angle ABC is a straight angle. That's what this is telling us. All right, or a 180. That's telling us from here to here is a 180-degree angle. That's all this means. Now, the next thing I might tell you is the measure of angle ABD. Sorry, we got to get that right. ABD. That measure is going to be 38 degrees. Okay, still not enough information to do very much, but this angle right here from there to there is 38 degrees. All right, now I'm going to add this other piece of information. I'm going to tell you that BE, the ray, bisects angle DBC. So that's this one right here, the leftover. Find the measure of angle EBC. All right, that's what our job will be. Now, what I want my students to do is I want to break this down into two parts. Okay, what we studied before was something called a linear pair. I'm going to get rid of this EB part. Okay, so we're just going to focus on A, B, C, D. Now remember, angle ABC, the whole thing, its measure is 180 because it was a straight angle. So if I go all the way from A to B to C, it's 180 degrees. Now I'm telling you that from here to here was 37. I'm sorry, 38. 38 degrees. Now, what we should be able to figure out is what's left. Okay, so what we would do is, let's just call this x. Okay, x plus 38 should equal 180. That's angle addition postulate. You might hear your teacher speak of that. Subtract 38 from both sides, and we get a 142. Now, this is great. This is great to know. Okay, we're going to come down here. All right, what we've just accomplished is we have 38 degrees up to here, and we got 142 from here to here. Now we can go back to the original problem where it's tricky, and we can say, all right, what we have is this big angle right here. We're going to ignore the other part now. We know that it's 142 degrees altogether, but then we bisected it. Okay, what does that mean? We cut it into two perfectly equal parts. So 142 divided by 2 is 71. So it's 71 degrees from here to here, and it's 71 degrees from there to there. So what's our answer? This is the work right here. Measure of angle EBC is going to be 71 degrees. All right, so that's how bisect will work. Thanks so much, and I'll do something with complementary next video.